Hi guys, today I want to discuss the probability of a widespread theory of Zecharia Sitchin that ancient Sumerian gods, the Anunnaki, were advanced aliens that came to Earth to mine gold. This theory came from Sitchin's interpretation of the Sumerian clay tablets, which also proposed that these godlike Anunnaki aliens bioengineered subspecies such as Igigi and humans to be their slave labor to work in the mines. It's a very intriguing hypothesis with many followers. In this video, I won't get into the accuracy or credibility of Sitchin's translations and interpretations, but solely focus on whether it's conducive for a highly advanced alien civilization to travel interplanetary in order to mine on another planet, and even go to the extent to bioengineer new species to assist their mining projects. The extended questions are, if an extraterrestrial civilization was advanced enough to reach faraway planets in our solar system, would it mine gold, other metals, or minerals from Earth? If aliens were really collecting something valuable from our planet, what would that be? Since we're talking about the possibility of ancient gold mining in Mesopotamia, let's first take a look at the gold artifacts from that region, which can illuminate their source of gold. If these Mesopotamian relics used gold extracted from local hard rock or alluvial deposits, then the ancient gold mine concept has grounds. Sumer was the world's first urban civilization, and Sumerians are among the first to use soldering techniques for creating beautiful gold and silver jewelry. As of the 3rd millennium BCE, gold objects are frequently found within burial contexts in Mesopotamia, but there are no metal-bearing deposits in the region. A 2018 analysis of the chemical composition of artifacts from sites including Kish, Nippur, Hisar, and Gora identified 2 rich alluvial deposits in Iran and Afghanistan as potential source for the geological origin of the gold from Researchers stated that the raw gold used by Mesopotamians was not found locally, but through long-distance trading over 5,000 years ago. This suggests there was likely no significant gold reserves in ancient Sumer, and gold was imported. In that case, even if ancient aliens came to Earth to mine gold, they wouldn't have chosen Mesopotamia as the setting of their mines. Here is a graph of the largest reserves of gold in mines of 2022 by country. Australia and Russia hold a large share of the world's gold mine reserves, accounting for 8,400 metric tons and 6,800 metric tons, respectively. None of the Middle Eastern countries are on the list. Here is the list of the top 10 largest gold mines by production. Again, no Middle Eastern countries there. If Anunnaki came to Earth to mine gold, why didn't they operate their mines in the areas with the largest gold reserves? Assume that Mesopotamia used to have a ton of gold, which has been depleted by the Anunnaki mines. Why didn't these supreme beings go after other sites for gold? Why did they leave so much gold untouched around the globe? On a different note, if some extraterrestrials or ETs were so advanced that they traveled to another planet to mine ores to send back to their home planet, why didn't they take mining machinery and robots with them, but instead brought biotechnology equipment and then go through the trouble to create new species to act as manual labor to work in mines? It would have taken much more time and effort to create, grow, and maintain human laborers than setting up fusion-powered machinery. These aliens were capable of space voyage. Sure, they would have fusion reactors or even better power sources, right? The efficiency difference between mining machines and human labor would be drastically different. Why would advanced beings choose the lengthy, far less efficient way? Time would have been super sensitive and valuable to these godlike aliens, since they would have traveled through space-time and dealt with time dilation. Would they spend decades on Earth to experiment on creating new species and wait for humans to grow and mature to work in their mines? I don't think so. It's possible that some alien craft crash-landed and required mending with available local materials, though I doubt these interstellar spacecrafts would be made of regular metals or alloys, but more likely ultra-lightweight, ultra-strength mechanical metamaterials of sort, which means in order to repair their futuristic crafts, particular materials would need to be manufactured specifically and cannot be fixed by soldering random metals or minerals together. It would make more sense for aliens to bring backup repair materials within the craft than trying to recreate appropriate patches on a foreign planet. Wouldn't you agree? Therefore, the idea that ancient aliens came to planet Earth to mine gold in Mesopotamia or anywhere else on Earth is not sound. But other questions persist. For example, if a highly developed alien civilization can travel through galaxies to another planet, would it mine metals to send back to their home planet? Would ETs come to Earth to mine ores? Does Earth have special elements, rare or non-existent on other planets, that are worth aliens' energy, time, and effort to travel afar and obtain here? It's foreseeable that one day we could send astronauts and machinery to Mars and build colonies. The abundance of volcanic features, together with widespread cratering, are strong evidence for a variety of ores on Mars. These ores would be very useful for potential colonists. But would any of these Mars ores warrant the extreme high cost of transport to Earth? Probably not. Plus, does Mars contain unusual materials or rare elements that are of great importance and lacking on Earth? There are 118 known elements in the universe currently. The first 94 exist naturally on Earth, with the rest being the product of nuclear fission. The most common elements in the universe are hydrogen and helium. These two elements comprise around 98% of all the elements in the universe. In terms of number of atoms, here are the 10 most abundant elements in the universe. They account for about 99.3% of all the atoms in the universe. The Sun, like other stars, is a ball of gas. It's made about 70% hydrogen and 28% helium by mass. In our solar system, there are 4 terrestrial planets: Earth, Mars, Mercury, and Venus, which are closer to the Sun, and 4 distant giant planets, including 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. Terrestrial planets are also called rocky planets, and they are mostly made of rock and metal with high melting points. All have roughly the same structure: a central metallic core, mostly iron, a surrounding semi-liquid mantle with a compact, rocky crust. The giant planets are substantially different. They may not have solid surfaces. Gas giants are composed mostly of hydrogen and helium, while the ice giants are mostly made up of volatile substances, such as water, ammonia, and methane. Based on current understanding, these planets are the way they are due to the formation and evolution of our solar system. The nebular hypothesis propounds that the solar system formed from the gravitational collapse of a fragment of a giant molecular cloud about 4.6 billion years ago. Most of the collapsing mass collected in the center, forming the Sun, while the rest flattening into a protoplanetary disk out of which the planets, moons, asteroids, and other small solar system bodies formed. The accepted method on how the planets formed is accretion, in which the planets began as dust grains in orbit around the central protostar. Through direct contact, gravity, and self-organization, these grains formed into clumps up to 200 meters in diameter, which in turn collided to form larger bodies. These gradually increased through further collisions over the course of the next few million years. The inner solar system within the frost line was too warm for volatile molecules like water and methane to condense. So the planetesimals there can only form from compounds with high melting points, including metals like iron, nickel, and aluminum, and rocky silicates. These rocky bodies would become the terrestrial planets. So mineral composition-wise, terrestrial planets like Earth and Mars probably share a lot in common. Such planets' compounds are very rare in the universe, comprising only 0.6% of the mass of the nebula. So terrestrial planets could not grow very large like giant planets. It's suggested that the size limit to terrestrial planets is about 5 to 10 Earth masses, something like 2 Earth radii. Even though terrestrial planets are much, much smaller and only account for a tiny fraction of the masses in the universe, they are quite common. Kepler Space Telescope observed that there are billions of planets out there, and a good chunk of those planets might be rocky and habitable. Our galaxy alone holds an estimated 300 million of these potentially habitable worlds. In our solar system, 3 of the 4 terrestrial planets, Venus, Earth, and Mars, have substantial atmospheres. All have impact craters and tectonic surface features, such as rift valleys and volcanoes. Their size, radius, and density are all not too far apart. If one wants to mine metals and minerals, the obvious choice will be terrestrial planets. Since these rocky planets naturally contain heavier elements with high melting points, it's reasonable to propose that they might largely be constituted with similar elements, which implies that the mining of a terrestrial planet in our solar system or on another rocky planet outside the solar system might reveal more or less the same elements. For that reason, if an advanced civilization really wanted to do some interplanetary mining and didn't mind the cost and effort, they could choose a nearby terrestrial planet instead of traveling far away to another planetary system. Even if the aliens could bend space-time and cross galaxies through wormholes, I assume it would still demand less energy, be easier and cheaper to go somewhere closer to their home planet. Consequently, it's unlikely a super advanced alien civilization would come to Earth to mine metals or minerals, which they can basically find on all rocky planets. If they do visit us and mine any earthly materials, they would go after the unique things of Earth, which set Earth apart from other terrestrial planets. What on earth could be so precious to pique the interest of highly sophisticated aliens and justify their uber high-cost space travel endeavors? The answer is the complex life forms on Earth. If there is anything that's worth collecting from Earth, it wouldn't be gold or gems, but biological samples, especially the ones from the most intelligent animal, humans on a blue planet. We humans are carbon-based. Considering the 118 elements known to man, it's strange that organic life is mostly constructed using only 6 elements, which are oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. Carbon is a primary component of all known life on Earth. Carbon's unique extraordinary thermodynamic and chemical properties render it so superior to other elements. Carbon atoms can form strong bonds with other atoms, including other carbon atoms, which allows for the formation of complex molecules like DNAs and proteins. Some speculate that there could be life forms which utilize carbon's closest cousin, silicon, to form silicon-based life. Some say that advanced aliens could be silicon-based. However, this might not be true. MIT researchers published a paper in 2020 presenting their study on the potential of silicon as a building block for life. They explored silicon's chemical complexity in diverse solvents found in planetary environments, including water, cryosolvents, and sulfuric acid. Their comprehensive assessment concludes that in no environment is a life based primarily around silicon chemistry a plausible option. Other scientists also noticed that silicon is more reactive than carbon. Double-bonded silicon molecule, unlike double-bonded carbon, is transient. Its instability eventually forces it to part into single-bonded silicon atoms. In contrast, carbon molecules, such as hydrocarbons, one of the most crucial species of molecules to sustain life, is neither too frail to easily break down, nor too rigid to deter plasticity and adaptability. Carbon is also more abundant in the universe. On Earth, though, silicon is more abundant than carbon. Well, life didn't originate using silicon, which means that in Earth-like environments that can spawn life, carbon-based life succeeds. The laws of physics, biochemistry, and thermodynamics make carbon the most likely candidate as the basis for complex organic molecules. Thus, advanced alien lives are most likely to be carbon-based as well, and it would resemble life on Earth. In equivalent areas of the genome, humans are 98.8% genetically similar to chimpanzees, 75% genetically similar to chickens, and even share approximately half of our DNA with bananas. Plants and humans are more alike than we think. How similar would the genome of advanced aliens be with humans? All in all, we Earthlings might not be that different biologically from aliens. Our DNA likely shares something in common with aliens. An advanced extraterrestrial civilization on a distant planet would sure be very curious in studying the diverse carbon-based complex life forms on Earth. So, if there are supreme beings who have been around much longer than humanity technological-wise and possess the ability to travel through space-time, the things they will likely covet and collect from our planet would be biological samples taken from humans and animals. You might immediately think of the mysterious cattle mutilation cases and the alien abduction claims. Some said that aliens came here to breed with humans in order to extend and increase their own genetic diversity. These conjectures, in my opinion, have more merit than the Anunnaki alien gold mining story. I may do a video to explore this. If you have any insights, please leave me a comment. If you like my video, please subscribe to my channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.